Another case study we want to discuss today is about the power generation optimization. The client we have, they wish to conduct a comparison study between the performance of two identical air supply units in their coal-fired power station. So basically what was happening, there are two identical air supply units with the similar coal quality going through their boilers, but they've been noticing some sort of deviation between two units and some underperforming basically effects on one of the units. So they've been trying to isolate the underlying cause of the loss of energy production as well as excessive energy consumption and reliability issue. What we did here, we tried to model two units by ingesting almost 4 years of historical data they had. We selected the critical tags of air supply units, including forced and induced draft fans, boilers, mills, and basically we tried to isolate the cause of the deviation from a normal operation for each of these tags. What we concluded, as we see here, there is a severe deviation from the model prediction in the gas air heater. This is involved with the inlet pressure and also the differential pressure, but as we see, the outlet pressure, which is linked to the induced draft fan, doesn't show any sort of deviation. So what we concluded here, it was the possible pressure loss between the gas heater chambers. So as we know, the forced draft fan, they produce the positive pressure, and from the other side the induced draft is on negative side. So basically they're trying to exchange the temperature in the gas heater, so there is a possibility of basically from the positive pressure leak goes towards the negative pressure, as we see here. The issue was causing loss of energy production as well as excessive energy consumption and reliability issues here. In fact, there are multiple studies out there that the air heater seal repair and upgrade across coal-fired power plant can lead to an improvement up to 0.5%, which in plant heat retention, which in basically it can be translated to $280,000 saving of fuel costs for a 200 megawatt plant, similar to what we had here.